Alright, so welcome to Math with Alex. That's cool. And we have bearings, and we are doing adding in the trigonometry with the application of the cosine rule. Just some harder application of bearings, which is seen in our upcoming test, and also our future test in the HIC, and I'm sure our Year 11 end of year exam. Anyway, what are bearings? By definition, an angle measured clockwise from north that shows the direction from one point to another. Bearings, they can range from finding the direction of travel between 2 points to finding the distance between those 2 points. Rules for bearings: always start at north when measuring the bearings. Measure the angle clockwise from north. Write bearings in 3 digits, i.e., for example, 65 degrees becomes 065 degrees. This is called true bearings. In certain situations, bearings can be written in compass form, so that 65 degrees that we just mentioned before would become north 65 east, or n 65 degree symbol east. So a little trick for converting compass bearings to true bearings. So let's say we've got south 25 east. Let's get our little thing up. So that is north. So we've got the north, and then that goes all the way around to south. That's 180. Because it's south, we go all the way around to south. Then so obviously that 180, but then we are 25 east. So then we've got to come back that 25 east. That's what that little line is. And then, so as it says, go towards 25 degrees east. Then you just minus that from the 180, gives you 155, which is equivalent to south 25 east, but in true bearing form. The same works for north, but just, oh damn it, my camera's cutting that off. That's annoying. Anyway, so the same works for north, but you just start with 0 or 360 depending on if it's north or east. So this is an example of what one can look like. It's not a question itself. So you can have A, point B, little thing. So you got north, then you've just got the omega symbol. We're going, what direction do we need to travel to get to B from A, then 60 degrees. It's just like a little example of what one could look like, not a question itself. Obviously, you don't really have anything to work that out with unless you had a protractor. An example question. I'm not going to read these all out. I'll show you the answers in a second and how they work. I'll just give you a second if you want to read them. Actually, you should probably pause it. I'm not going to lie. Let's go to the next one. Eli walks from his house on a bearing of south 25 east. If he walks 5.7 kilometers, how far south is he from his house? So we've got Eli's house, got a little grid up here. Then we're going to, I always like to convert it, so we're going to go convert the 25 south 25 east to the 155, which is what it is in true bearings. So then we're just going to do our little thing. We know that in that little patch, well, I should probably explain that. Alright, anyway, so we go around 155 degrees. Then we minus that from 180, which gives us 25, which is what that angle is in the inside, which we are going to use to create our triangle to find how south it is. So we're going to make that 5.7 km across. Then x, that is the south, that's what we are trying to find. So we're going to use cos, because the x is going to be our adjacent side here, and then the 5.7 is going to be our hypotenuse. So cos 25 will equal x on 5.7. 5.7 times cos 25 equals x. Then x equals 5.2 km rounded to 1 decimal place. So a plane leaves Sydney and flies 100 kilometers due east, then 125 kilometers due north. Find the bearing of the plane from Sydney to the nearest degree. Alright, so what we've done here, I've just drawn it out already. Well, already drawn it up, I guess. So we've got Sydney, then we've got the plane, we've got the angle that we're trying to find, then we've got our two sides. So we've got the east, 100 km, then the north, 125 km. So what we're going to do here, we know that it's going east, north. We know that this angle, it's going to be tan. So tan theta, 125, then 100 km. There. 100. Tan theta equals 125 on 100. Then we're just going to flip it around, change it around. Tan minus 1, 125 on 100 equals theta. We're going to, the angle equals 51. So that's the inside angle. But if you remember our bearing rule, we always start from north and we go around. So what we're actually trying to find is that other angle. This angle in between the north line and that orange dotted line. So what we do to find that is, well, as you know, a full circle, 10360 degrees. So this portion, which is going to be our first 90 degrees. So that means we minus the 51 from 90, which gives us this angle is 39. Therefore, the plane is on a bearing of 39 degrees from Sydney. Alright, so Paris walks south from her home for 3.2 kilometers. Then turns west for 1.8 kilometers. Find the true bearing to the nearest degree of A. Paris from her home. Alright, so we've got this. That's a little grid. I don't know why that came up first. Maybe I did that wrong. Anyway. So we're going to start at the home. Come south 3.2 k's. Come across 1.8 k's. And then we get where Paris is currently. So this is not obviously the scale, 3.2 and 1.4, they're not that big. But that's not important. Just thought I'd get that out of the way. Alright, so we're finding that large angle that comes around and meets us at that dotted line. Because that is the distance Paris is from her home. So now to find that, we need to find that angle on the inside, which I'm going to call theta here. And as we already know, from north to south is 180, so we just need to find that end bit. We don't need to find the entire angle, because we already know that from the north to the blue line is 180. And we're just going to use tan here, because that theta angle is going to be tan, because we have the opposite and adjacent angle. So tan theta equals 1.8 on 3.2. Then tan minus 1, that, what I previously said, equals theta, which is going to equal 29 degrees. Then we add that to 180, 209. That is going to be the angle she is from her home. Now, to where she is now. That is a different story. Her home from where she is now. But, so we're going to call that omega. As you can see, if you remember our alternate angles, theta and omega, they're alternate. So that means they're equivalent to each other. So, because they're alternate angles, therefore, theta must also equal 29. As omega must equal 29, sorry. Now we're going to get to some of our harder applications of the bearings. Now, this first question, you may look at it and say, that's not really bearings. But it really works on the application of turning words to diagrams, which is probably the most important part of bearings. So I've added it in there, just some extra practice of doing it, and just chuck it in there. Extra work, extra fun. So now, two cars leaving an intersection at the same time. One is traveling 70 kilometers an hour along a straight road, and the other car is traveling 80 kilometers an hour on another straight road. After 2 hours, they meet. They are 218 kilometers apart. What angle to the nearest minute do the roads meet at the intersection? Alright, so first thing we're going to do, after 2 hours, they're going 70 kilometers an hour and 80 kilometers an hour respectively. So after 2 hours, we need to times those numbers by 2. 70 times 2, 140. 80 times 2, 160. So let's draw up our little thing. We got 140, 160, 218. Then we are finding omega. So we're going to use the cosine rule, the application of it. It's very important here. Yes. Alright. So we're going to use the cosine rule when we have three sides and we're looking for the angle. So the cos of omega equals 140 squared plus 160 squared minus 218 squared, 2 times 140 times 160. I forgot to say on. Well, that's not very good. Okay, so the cos of omega equals negative 0.05, Then we're going to swap that around, swap. Do cos minus 1 equals omega. Omega equals 92 degrees, 58 minutes. That's going to be the answer to that question. Okay, so this question, have you read before? It's from the 2020 HSC, pretty important application of bearings right here. Good to practice. Mr. Ali and Mrs. Brown and a group of students were camping at a site located at... I don't know where it's located at. Mr. Ali walked with some students on a bearing of 0.35 degrees for 7 km to a location. Mrs. Brown and the rest of the students, they walked on a bearing of 100 degrees for 9 km to the location. Now that it looks pretty crowded, and it is pretty crowded, but we're going to have a look at our little thing. So that blue thing, that's going to be representing the angle that Mr. Ali took to get to point A. Then the green is representing the angle that Mrs. Brown's class took to get to point A, and orange is going to be the angle that we are trying to prove is 65 degrees, 3500 theta. So if you see the diagram, you can clearly see that the blue plus the orange must be equal to the angle of green. So simply, we just need to take the green away from the blue, the blue away from the green to get the orange. So that means 100 minus 35 equals 65 degrees. And now we are on to part B to find the distance. Alright, so as we know, Mr. Ali took 7 km little walk with his students, and Mrs. Brown took a 9 km walk with the other students. So we are now trying to find the distance between each other, which is going to be this orange line right here. Actually, it's more of a yellow line. But anyway, we're going to call it x real quick. So 2 sines an angle, we're using the cosine rule for a side. X squared equals 7 squared plus 9 squared minus 2 times 7 times 9 times cos 65. So we're just using the values that we already have here, and the value of the orange little thing that we proved is 65 in the previous question. Now x squared equals 76.705 blah blah blah. Then x, so we just square rooted both sides there, it equals to 8.76 kms, 2 decimal places. Now on to part C, the final part. Whew. So now we need to find the bearing of Miss Brown's group from Mr. Ali's group. Give your correct answer to the nearest degree. Okay, so what we are going to do here, I've skipped ahead accidentally, but it is fine. I'll explain what is going on. So on the left here, this little angle, theta equals 180 minus bracket omega minus 35 degrees. That is what will equal the final answer. Alright. So now this 35 degrees that's been added around point A, it's going to be camp AC. That is going to be an alternate angle from the original 35, which equals that. Now, because we are finding the bearing of Miss Brown's group from Mr. Ali's group, I've created a point on A, which is Mr. Ali's current location, and we are going to go around to that dotted line, and that is the bearing that Mr. Ali is from Mrs. Brown. And we'll call that theta. Call it theta, because we're not using theta anymore. And then this little grey line here, we're going to call that omega. So omega is simply just from the yellow line to the line in which is between camp and A. So angle camp AC. I shouldn't have called that camp, that is probably a bit annoying and confusing, but without further ado, that equals 35 as it's an alternate angle as I previously said. See, boom, boom, boom. Then the cos, so we're going to use the cos rule here, purely because we have 3 sides in 7 km, 9 km, and 8.76 km, and the cos of omega will equal 7 squared plus 8.67 squared minus 9 squared, then on 2 times 7 times 8.76, and that's going to equal, the cos of omega equals 0.36747 blah 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 blah. Then omega equals 69 degrees, and that's rounded. So now we're going to sub that back into that original little notation that I said, because we know that the only difference between the bearing and 180 is that little sliver. So we just need to find what that little sliver is, and that little sliver is going to be 69 now, minus 35, god. Then that means theta equals 180 minus bracket 69 minus 35 degrees bracket, and that means the bearing that Mrs. Brown's group is from Mr. Ali's group is 146 degrees.